What's a factor? Well, let's look at these problems. 2 times 3 times 7 equals 42. The factors are the things that are getting multiplied together. So 2 is a factor, 3 is a factor, and 7 is a factor in this particular problem. Here's another one. 8 times 3 is 24. 8 is a factor and 3 is a factor. So the things that are getting multiplied are the factors. You could either put dots between factors, or you could write it with a parentheses around one of the numbers. 8 and 3 could be called the factors that way. Or you could have a parentheses around both of them. And you could have 2 or more factors. All right, let's list the factors of 15. So let's see if we could come up with all the numbers that go into 15. All right, so let's start with the number 1. Does 1 go into 15? Yep. Does 2? No. Does 3? Yes. Does 4? No. Does 5? Yes. Does 6? No. Does 7, 8, 9, 10, 11, 12, 13, 14. None of those go into it until we get to 15. So the factors of 15, there are 4 of them. 1, 3, 5, and 15. Later we'll go over how to get a list without having to go through one at a time, the way I just did this one. All right, before going on, let's review just 3 divisibility tests. All right. 2 is a factor of any number that ends in 0, 2, 4, 6, or 8. In other words, if the number is even. So some examples of numbers that 2 goes into, well, like 38 because it ends in an 8, or 506 because it ends in a 6, etc. And if it ended in a 1, 2 wouldn't go into it, so 2 would not be a factor. All right, 5 is a factor of any number in 0 or 5. So, for instance, we could do 35, right, or 1010. Those are numbers that 5 is a factor of because it ends in a 0 or a 5. And 3. 3 is a factor of any number if 3 is a factor of the sum of its digits. All right, so this one, let's practice this again. So let's take the number, let's say 24. We all know that 3 goes into 24, right? But the way you know for sure is that when you add the 2 plus 4, you get 6. And 3 goes into 6. So that's an easy one because we already know that 3 goes into 24. So let's pick something that we might not realize that 3 went into it. Let's say we had 87, and we want to know if 3 goes into 87. Well, 8 plus 7 is 15, and since 3 goes into 15, then 3 will go into 87. All right. Now, if we would have picked 85, it would not have worked because 8 and 5 add up to 13, and 3 does not go into 13. So we're going to be using this for this next part. The next part is, what's a prime number? Well, a prime number has exactly 2 factors, 1 and itself. Now note, 1 is the only factor of the number 1, so it doesn't have 2 factors, so the number 1 is not prime. So prime number has exactly 2 factors, like 7. 7 is prime because the only factors of 7 are 1 and 7. No other number goes into 7 evenly. So let's say we were giving a list and asked to circle all the prime numbers. What I've decided is to give you a list of the numbers from 2 to 105. I've skipped all of the even numbers except 2. There's only one even prime number, and that's 2, because all the rest of them 2 will go into evenly, so they won't be prime. So here's a list of odd numbers up to 105. So 2 is a prime number, so I would circle that. Okay. Now 3. 3 is 3 times 1, so there's only 2 factors, so 3 is prime. The only numbers that go into 5 are 5 and 1. The only numbers that go into 7 are 7 and 1. Now, 9. Basically, you could look back and see if any of these numbers go into it, and if so, then it's not prime. So I'm going to cross that off the list. 9's not prime. 11 is only 11 and 1. 13, only numbers that go into 13 are 13 and 1. 15, you look back here and you see 3 goes into it, so you can cross off 15. So that's basically the way to do it. Now, there's a little trick, and I'm not going to explain why this is true right now, but actually, if you're going to check to see if any of these numbers were prime all the way up to 105, the only numbers you really have to check are to see if they're factors are 2, 3, 5, and 7. For smaller numbers, you don't even have to check 7. But to make it simple, I'll say all the numbers I listed on this page, you only have to see if 2, 3, 5, or 7 goes into them. Now, we know 2 doesn't go into any of these because they're all odd. So basically, we're just going to use the divisibility test for 3 or 5, or we might have to divide by 7. Use a calculator, scratch paper, or if you know the divisibility test for 7, you can use that. So I'm going to do a few more with you, and then you could try it, or you could put it on pause and go all the way through on your own, if you like. All right, 17. So we're just checking to see if 3, 5, or 7 goes into it. Nope. So 17 is prime. 19, that's prime. None of those numbers go into 19. 21, 3 goes into, so cross it off. 23 is prime. None of these 3 numbers go into 23. 25, that's 5 times 5, so that doesn't work. 27, 3 goes into it. And 29 is prime. Okay, go ahead and put it on pause and see if you could get the next 2 rows of numbers all the way up to 61. See how you do. Did you put it on pause and do it? All right, I'm back. All right, so I'm going to circle the ones. 31's prime. 31 is not because 3 goes into it. 35 is not because 5 goes into it. 37 is prime. 39 is not because 3 goes into it. 41's prime. 43 is prime. 5 goes into 45, so that's not prime. 47's prime. And 49 is 7 times 7, so that's not prime. Now, 51. Well, does 3 go into that? Just add the digits. 5 and 1 is 6, right? And 3 goes into 6, so you know what? Not prime, since 3 goes into 51. 53 is prime. 55, cross that off because it ends in 5, so 5 goes into it. 57, does 3 go into that? 5 and 7 is 12, so not prime because 3 goes into that. 59 and 61. All right, getting the hang of it? Now be careful. Don't assume anything. If you want to know if a number is prime, you really are going to have to check. For the rest of the list here, you're going to have to check to see if 3, 5, or 7. 5's easy. Let's just cross off the ones that end in 5 or 0. Of course, none end in 0 because I don't have any even numbers. But 65, 75, 85, and 95, we could cross those off right away. So we're getting to a smaller list here. And you're going to do the divisibility test for 3, means add the digits to see if 3 goes into it. And then for 7, divide by 7. See if 7 goes into that number or not. So put it on pause and try that. Okay, hope you did it on your own first. Here we are, 63. 3 goes into that, so cross it off. 66, 3 goes into that. 67 is prime. 69, 3 goes into that. 71 is prime. 73 is prime. 77, 7 goes into 77, so cross it off. 79 is prime. 81, 3 goes into it. Or if you know another number goes into it, like most of you probably realize that's 9 times 9. That's another reason. It's got a factor besides 1 and 81. 83 is prime. What about 87? Add the digits, you get 15, so not prime, because 3 goes into 15. 89 is prime. 91. I wonder how many of you circled 91. Well, a lot of people think 91 is prime, but it's not. If you add 9 and 1, you get 10. So 3 doesn't go into it. We know 5 doesn't go into it. But 7, yes. 7 goes into 91 13 times. So 91 is not prime. Remember that. 91 is 7 times 13. It is not prime. You can't say, well, it looks prime. You got to really check it. All right, 93. 3 goes into that, so cross it off. 97, that's prime. 99, 9 goes into it, so cross it off. 3 doesn't go into 101 because if you add the digits you get 2, and 7 doesn't go into it. If you divide by 7, you get a remainder. Same thing for 103, and the last one, 105, 5 goes into that. I forgot to cross that off earlier. And so pretty quickly, we were able to list all the numbers, circle all the numbers up to 105 that are prime. You notice there's no real pattern. You never know. Sometimes there's 2 in a row that are prime, and sometimes there's a bunch in a row that are not prime. It's kind of random.